My name's Graham Charters. I'm the Liberty Product Manager, so I'm responsible for Open Liberty and WebSphere Liberty as products.
Hi, I'm John Buckley. I'm Product Manager for the Modernization tools.
Hi, I'm Dana Price. I'm the App Modernization Architect responsible for accelerating modernization to the cloud.
Hey, and I'm Cindy High, and I'm a WebSphere Migration Architect.
Okay, so let's get onto the materials. Okay, so the session we've got today is The Road to Liberty, a WebSphere modernization journey. And it comes in 4 parts. So I'll start by talking a bit about kind of context, industry observations, and so on. So how we got to where we are today and where we see the industry going. I'll talk a little bit about why we think Liberty is a great choice for modernizing your applications. Then I'll hand over to John, who will talk about modernization paths. And then John, Cindy, and Dana are going to cover deep dive material in modernization. And along the way, you'll see some demos. So I'll demo a bit of Liberty after the Why Liberty session, and then we'll see demos of mono to micro and so on. Okay, so background, industry observation. So you're probably on this session because you have existing enterprise applications. They maybe started out in the late 1990s when Java EE, or what became Java EE, was first created. And in that time frame, we created WebSphere Application Server. Other vendors created other application servers, such as what became JBoss EAP. And at the time, there were only a small number of specifications around Java EE, and Waterfall was the predominant methodology for creating applications, and environments were very constrained. So both in terms of infrastructure, so memory, CPU, etc. And so what we naturally created were monolithic applications. Now, we didn't call them monoliths at the time because we didn't have any other kinds of applications. And the focus there was really on keeping an application up and running, having it perform, scale very well, and so on. But it wasn't really a strong focus on kind of time to delivery and so on, and focusing on developer experience. But as the years went by, increased pressures to get new capabilities out meant that there was more pressure on developers to turn around updates and so on, and kind of lighter weight, more agile solutions were required, both in terms of methodology, but also in terms of technologies. And to address these needs, we created something called WebSphere Liberty. Now, WebSphere Liberty is a small, lightweight runtime kernel, and then we harvested the capabilities from traditional WebSphere application server as individually installable features. So what you could do is essentially customize a runtime to fit the needs of your application. And this happened to actually be a very good fit with where the industry moved beyond that. So as we moved towards the cloud and cloud native and microservices, there was a shift in terms of architectural style, in terms of how you build and deploy applications, such that you would have a kind of one-to-one correspondence between applications and server runtimes. And so because we can tailor the Liberty runtime to fit the application needs, that was a very good fit. Also, the lightweight nature of the Liberty runtime meant it was a great choice for putting in containers and then scaling out on Kubernetes environments. So the industry continued to evolve in terms of Kubernetes, and then platforms such as OpenShift. There was an increased pressure for open source, so we open sourced WebSphere Liberty as Open Liberty. And of course, Red Hat produced, as I said, OpenShift, and then later created Quarkus as a kind of compile to native lightweight runtime, which fits very well with serverless executions. And so I've talked about there being a shift. What does that actually mean in terms of shift to the cloud and Kubernetes? What's that mean in terms of real numbers? Well, this 2020 IDG survey shows that actually a lot of the applications that are on the cloud actually didn't originate on the cloud. So 54% actually started out as on-premises applications. But also customers are picking multiple clouds. They're not just choosing a cloud and then going with that as their answer. And so there's a need for essentially an OpenShift hybrid cloud approach. And lastly, things aren't standing still. So most customers are expecting that by the end of 2021, according to this survey, that most, if not all, of their applications will be on the cloud. And in terms of Kubernetes adoption, well, essentially Kubernetes is becoming the de facto container orchestration technology of choice. So these numbers are from the Red Hat open source enterprise open source report. So where 84% of customers are actually using containers either in development and or production. Most, so 72%, expect their container use to increase over the next 12 months. And actually 2/3 of customers who are interested in cloud native believe that Kubernetes is a very important technology, or actually extremely important technology. So there's a shift to the cloud, there's a shift to Kubernetes, but there's also a shift in terms of architectural styles. And we've heard over the past probably 5, maybe more years, lots of promotion, if you like, of the concept of microservices. But what we're actually seeing, I think, is, yes, microservices are great and they address certain needs, but they're not necessarily appropriate for all applications or even all companies. So there are many examples where microservices are successful, but there are also examples where people have done microservices. Maybe they've made mistakes, gone too fine-grained and gone back to something they call macroservices, maybe, such as Uber. But there are also examples where people tried microservices and actually went all the way back to a monolithic application, because what they actually did was they ended up with a distributed monolith rather than microservices. They were having to deploy essentially all their services together. So you end up with essentially the worst of both worlds. So what are the characteristics that lead people to choose different architecture styles? So this is an attempt at kind of summarizing the trade-offs between the different styles, or the pros and cons. Now, I won't read all of them in the interests of time, but let's pick out a couple of examples. So, for example, operational complexity. So if you're deploying a monolith, then you're deploying one application. And that application, you may be scaling it up to a few instances for HA reasons. Whereas if you're deploying microservices or functions, you're deploying lots of individual applications. You're going to have to automate those things in order to deal with that operational complexity. If we then look at things like network demand, so from a performance perspective, on the left-hand side where you've got a monolith, most of your communications for the application are actually going to be within the JVM, whereas once you move to a distributed model where you have microservices or functions and so on, then actually you've got a lot of network communications going on, which are going to impact the performance of your overall solution. But the benefit associated with that is you actually have independent processes that are separated by networks, and you've therefore got better fault isolation. So you've got the opportunity to cope with the absence of a particular microservice in your solution. Next, if you look at runtime demands, so I kind of alluded to this earlier, where on the left-hand side, monolithic applications, traditionally what we did is we deploy a server runtime and then deploy multiple applications into that runtime. So the focus there was on being stable, performant, managing the server as a first-class entity, and having a full API set. Whereas as we've shifted to microservices and functions, there's a need for a reduced API set. The runtime you want to be smaller because you're going to have more instances of it. You want it to be faster, and you want it to be embeddable, or essentially an embedded runtime. For example, it might come in as a lower layer in a Docker container. And then lastly is the kind of organizational team structure, where the key message here is you really need to make sure that your organization is set up to deliver the different architecture styles. If you have essentially a monolithic team structure and separate dev, test, and operational teams, then you're not likely to be successful trying to deliver microservices. Okay, so I talked a bit about kind of API needs on the previous slide. If we therefore map the kind of API needs of different architecture styles, we can see that actually with traditional style applications or monolithic applications, as I said, they typically have a larger API surface area requirement because they're doing more things in those applications. So you might have traditional WebSphere applications running into or JBoss EAP or Wildfly applications. And if you don't have requirements to be able to evolve those things, then it might be that modernization isn't the right thing for those applications. But if actually what you're trying to do is make those applications more agile, you're not necessarily even moving them to monolithic microservices or macroservices. They may be moving to a more modern, lightweight runtime that's going to help you be more agile with those monolithic applications is a good choice, so such as Liberty. But Liberty also, because as I said, with its the ability to kind of subset the runtime, so you can take it all the way down to a kind of very small, perhaps servlet runtime. You can essentially span monoliths, macroservices, and microservices, and give you a kind of single runtime to support the different architecture styles. However, because Liberty doesn't have a compile to native capability, and it's not really designed as a kind of serverless functions runtime, then if you're going to go over to the functions side of the world, then you probably want to pick something else. Okay.